guys. I miss you guys a lot on Friday, so I hope that you did really well for the sub. I wanted to talk about that worksheet that I gave you on Thursday, and that will be due tomorrow. I mostly just want to talk about the table, so the table that looks like that. So make sure that you get that out while you're looking at this, so then that will help you. But I want to go through some of the examples so you understand what to do. So I think that the rest of the worksheet is self-explanatory, but if you have questions, then after you watch the video, post a comment on the blog, so then that way I can see if you still have questions on something else, and then I can address that on the blog, and we can talk about it tomorrow in class. So on the table, I want to do letter A. So before we even do letter A, though, I want you to look at some of these things. So you have your name of your element, and then you have your symbol, so you already know what that stuff means. But then there's this letter Z. The only thing that Z stands for, it's just a symbol that chemists will write to mean atomic number. So Z just represents atomic number. That's it. So, and again, you know that the atomic number is the same thing as the number of protons that are in an element or in an atom. So Z just represents atomic number. Now the letter right next to that is A, and so if Z represents atomic number, then A is probably going to represent atomic mass. So why they labeled this Z and why they labeled this A, I have absolutely no idea. It was just something that chemists did a long time ago, and for some reason it stuck. So Z is atomic number, A is atomic mass, and you know that the atomic mass is just found on your periodic table, and you know that that's the number of protons and neutrons in an element. So it's those two added together. You know the number of protons, so this column for the atomic number should be exactly the same as your proton number. So those two columns should be identical. Next you have your number of electrons. Next you have your number of neutrons, and you can find your number of neutrons by taking the mass number minus atomic number, right? You already know that because you're pros. And then we have this isotopic symbol, and I'm going to explain what this means in just 1 second. Okay, so let's do letter A. I'm going to do letter A. So I know that the symbol that gave me that is Na, so you know then that Na stands for sodium. So let's write the name in there, sodium. Okay, so I have sodium. And now I also need to now look at my periodic table and find the atomic number. And I know that the atomic number for sodium is 11, so I'm going to write atomic number is 11. Also looking at my periodic table, I can find the mass number of sodium, and then I know that if I round that to the nearest whole number, it should be 23. Okay, so here's where we are so far. I have sodium. I know they gave me my symbol Na, so that's how I knew it was sodium. It has 11 protons, and the mass number is 23. So now let's write the number of protons here. And I know the number of protons because the number of protons is the same thing as the atomic number. So let's write 11 there. Since they didn't give us a number of electrons, we're assuming then that it's neutral. So let's just say that my number of electrons would be equal to the number of protons. So there's 11. Now I have number of neutrons. Number of neutrons. So I can find the number of neutrons by taking mass number minus atomic number. So I'm going to do 23 minus 11, and then I'm going to get 12. Okay. So now the only thing that I have left here is this isotopic symbol. Since my number of protons and my number of neutrons are equal, it's just going to look like the regular symbol that I wrote over here, or that they gave you, Na. So we're just going to write Na. So that is how the first one will look. Now, that is an example of a neutral atom. So I want to do an example of something that's not going to end up being neutral, so you can see the difference between them. So let's do B. On B, they gave me an atomic number of 17. So I'd look on my periodic table and I would see, okay, what has an atomic number, or what element has the atomic number of 17? And you should immediately find chlorine. So on the name, I'm going to write chlorine. And I know the symbol for chlorine is Cl. So right now I have this. I have chlorine, I have Cl. They gave me an atomic number of 17. Also looking at my periodic table, I can find that mass number, and that mass number is 35. Okay. So we have our atomic number 17, we have our mass number 35. Now I need to determine the number of protons that chlorine has, and I know that chlorine has 17 protons because the atomic number is 17, because those are the same thing. So I'm going to write 17 there. Okay, now they gave me an electron count, but that's 18. And in a neutral atom, the number of protons and the number of electrons should be the same. So this is telling me that this should not be a neutral atom. So in this case, chlorine actually has a charge. We're going to figure that out in just 1 second. I want to do the number of neutrons though first. So to find the number of neutrons for chlorine, I'm going to take the mass number minus the atomic number. So I'm going to take 35 minus 17, which would give me 18. Okay, so I have everything filled out except for this atomic symbol, or isotopic symbol, I'm sorry. So on this, I have 18 electrons, and I have 17 protons. So if I think about that, I have one more electron than I have a proton. Electrons have a negative charge, and protons have a positive charge. So if I have one more negative charge than positive, overall I have a net negative charge, right? That should make sense, because I have 18 electrons but 17 protons, so I have one extra negatively charged particle. So in this case, chlorine has to be negatively charged by one extra electron. So I would write chlorine's isotopic symbol as Cl with a -1 charge. And I write it this way because there's 18 electrons and 17 protons. I have one more electron than I do a proton. So because I have one more electron, this overall thing is not neutral. It actually has a net -1 charge. I want to do another one. I want you to skip all the way down to E. So E would be iron. Now, they actually gave us the name for iron, so we know that the symbol for iron is Fe, so we're going to write that in. I know that the atomic number for iron is 26, so I'm going to write that in next. And I know the mass number is 56 by rounding, so let's write that down. If I knew the atomic number was 26, then I know the number of protons is also 26. And to find the number of neutrons, I'm going to take 56 minus 26, and that's going to give me 30. Okay, so now I'm left with this. I have my iron here, my symbol. I knew my atomic number was 26 by looking at the periodic table. I knew my atomic mass was 56 by looking at the periodic table. I know the number of protons is equal to the atomic number, so 26. They gave me the number of electrons, and then my number of neutrons was 30 because I just took 56 minus 26. Now, we have to write this isotopic symbol. I'm always going to look at number of electrons to number of protons. So my number of protons is 26, and my number of electrons is 24. So in this case, do I have more electrons or do I have more protons? So number of electrons was 24, number of protons was 26. Which one do I have more of? Should be saying protons. I have 2 more protons than I do electrons. So because I have 2 more protons, 2 more, and protons are positively charged, iron is going to have a +2 charge because I have 2 protons. I have 2 more protons than I do electrons. So let's see how I'm going to write this symbol. I'm going to write Fe with a +2 charge. So I'm going to have Fe with a +2 charge, okay? So, again, that's because I have 2 more protons than I do electrons, so because of that, this iron becomes charged. So, Fe +2. Now, I want you guys to try to do the rest of those, and again, if you have any questions on them, then make a comment on the blog, so then that way we can talk about it. before class tomorrow. But if we still have questions on them tomorrow, we'll talk about that in class. Now, before I stop the video, I want to at least touch on one little topic first before class tomorrow, and that's something called isotopes. And an isotope is an element that has the same number of protons but a different number of neutrons. So isotopes are elements that have the same number of protons but a different number of neutrons. Now, I want to give you some examples of what I mean by this. And in third bell on Thursday, Kelly asked a really good question about why all of the atomic masses on the periodic table were decimal numbers and why they weren't just straight whole numbers. And that's a fantastic question. So the reason that all of the atomic masses on the periodic table are decimal numbers is because all of the elements on the periodic table have an isotope, or they are isotopes. So, for example, I want to talk about hydrogen. Hydrogen has 3 isotopes. It has an element that looks like, and I'm going to write the nuclides for these, and you know what a nuclide is already because we talked about that on Thursday. And a nuclide is something where we write the symbol and then we write the atomic number and the atomic mass. Now, the atomic mass goes on the top and then atomic number goes on the bottom. So here are my examples. I have hydrogen with 1 proton and then an atomic mass of 1. I have hydrogen with 1 proton, atomic mass of 2. I have hydrogen with 1 proton and atomic mass of 3. Now, according to that, those are all the isotopes that hydrogen can have. It can have a mass of 1, it can have a mass of 2, or it can have a mass of 3. The reason that the atomic number stays the same is because an isotope will always have the same number of protons. And if I change the number of protons, we'd have a totally different element, right? So if we had a totally different element, it wouldn't be hydrogen anymore. So proton count always has to stay the same. The only thing that will change on an isotope is the mass number. So that's what you see here. You see the top numbers change. So I had 1, 2, and then 3. So the mass number changes. The number of protons didn't change, but the mass number changed because I added numbers of neutrons to each of those mass numbers. So in hydrogen 1, it had 1 proton and 0 neutrons. I knew that because I took mass number minus atomic number. On hydrogen 2 has 1 proton. I mean, it has to because it's hydrogen. And I knew the number of neutrons because I took 2 minus 1, which will give me 1 neutron. On hydrogen 3, I knew that it had 1 proton, again because it's hydrogen. And I knew that it had 2 neutrons because I took the mass number minus the atomic number. So the only thing that changed here was the number of neutrons. So these are isotopes. Now, if you look on your periodic table at the atomic mass of hydrogen, you would see that the atomic mass is 1.00079. The reason that it's that is because hydrogen 1, that first isotope of hydrogen, is 99% abundant in nature, which means that of all of these isotopes here, I find this one 99% of the time. These two are so negligible, they're so rarely found in nature that this one really overcomes them all. So that's why the mass is so much closer to 1 than it is to 2 or 3, because this one is the one that is mostly found in nature. Now tomorrow in class we're going to talk about isotopic abundance. And then I haven't decided yet if we're going to do the Candium lab tomorrow or if we're going to do it on Tuesday. So just know that for Monday and Tuesday we're really going to focus on something called isotopic abundance. I think that's all that I have to share with you today. So whenever you look at the video, if you still have questions, write comments on the blog, and then that way I will check them as soon as I get that on my phone. I will see you guys tomorrow. Bye. Have a good day.